First, cross-section of copper wire and describe the material. Current rating of the cable is depend on the cross-sectional area. Multi-core copper conductor are produced by two shapes, circular conductor and segment conductor. The segment conductor consists of 5 layers. The first layer is conductor, continued by insulation, bedding, wire and mooring, and the lastly is outer sheath. The word copper comes from the Latin word cuprum, which means ore of Cyprus. This is why the chemical symbol for copper is Cu. It has many extremely useful properties, including good electrical conductivity. This means that the resistance of a length of copper wire is relatively low. Next, copper is low in the reactivity series. This means that it doesn't tend to corrode. This is important for its use for pipes, electrical cables, and radiators. Lastly, copper can be joined easily by soldering or brazing. This is useful for pipework and for making sealed copper vessels.
So, I'm going to describe the microstructure of the copper wire. Most copper wire is produced using a drawing process in which plastic deformation leads to the changes in grain size and crystallographic texture. During the first stage of the deformation, the grains are divided, change shape, and also elongate in the direction of the stress. It also creates a large amount of point defects. During the deformation, a certain amount of energy is restored in the deformed microstructure, mainly in the forms of dislocations. However, the structure disrupted cannot be adjusted to a general industrial use. Therefore, a definite contribution of thermal energy is required to restore the physical structure and properties. Previous studies had also shown by applying severe plastic deformation can lead to improvements in mechanical properties. The patterns in image B, which represents a portion of the grain boundaries in the wire, increase in the length in the longitudinal direction, and image A show the reduction in width in the transverse direction. The shape of the grains became increasingly long and thin. This texture is frequently observed in the wire's drawing and is known as the texture of fiber or fibrous texture because it resembles the arrangement of fibrous material.
Okay, next we move to development of microstructure. So to make copper wire, we use wire drawing technique, which involve the material which contain the original grain will go through to a roller and transform to elongated grains. So when the material have the elongated grain, it will increase the surface area of grain boundaries, and also when the surface area increase, it also will increase the internal energy. So it also will increase the dislocation, which makes the material more stronger and less ductile.
The next process after cold working is recrystallization and kneading, which is involve no phase transformation. Okay, actually, when heat is added, this elongated grain will have lower internal energy, and also it increase in atomic diffusion. Also, the number of dislocation will decrease, and the strength of this material will decrease, and the ductility will increase. When the heat is added, actually the elongated grain will grow into small equix grain. Okay, this is when is the first step. When more heat is added, the grain will grow into the original grain structure.
Now, I will relate the microstructure with materials property. For copper microstructure, its atom has 29 electrons and an unpaired electron, which contribute to most of its properties. Thus, we can describe the properties of the copper wire based on its microstructure. For the mechanical properties, the copper wire is a ductile material due to the ability of the atoms to roll over each other to a new position without breaking the metallic bond. These delocalized electrons are the outer shell atoms free to move throughout the giant lattice. If one layer of the metal ions in an electron sea slide over another, the crystal structure doesn't fracture and it will only deform. The copper wire also is a good conductor of electricity and heat. It is because for thermal conductor, heat energy is picked up by free electron as an additional kinetic energy and transferred throughout the rest of the lattice. Since copper atom has many free electrons in the valence, so when the outside source of electrons was pushed to the wire, it will move throughout the wire at the same rate. When many copper atoms get together, they share electrons, so the electrons form a conduction band and encompass all the atoms. For optical properties, the copper wire is classified as an opaque material as it is impervious to the transmission of visible light. The copper wire, which consists of partially filled high-energy conductor bonds, will use its energy to excite electrons into unoccupied states, and it also will absorb all energy from the light photons. Last but not least, copper wire has a diamagnetic property, which means it will be repelled by a magnet. This happened because copper atom has more paired electron compared to unpaired electron. Since copper atom has only one unpaired electron, thus the paramagnetic contribution scale with the number of these electrons is too few. Hence, copper wire shows diamagnetic property.